Hey, and hello, everyone. Welcome to the June edition of the 2021 Geograph webinar series. I'm Bruce Smith, CEO of Geograph. I'll be your host today. We're going to be talking today a little bit about fiber to the X network design. And something you may not know, once upon a time, I spent about 20 some odd years as a telecom engineer. Part of my passion and excitement was doing network planning and design along with construction, management, and building networks really all across the country. Been in your shoes, and so I kind of anticipate some of the angst you're going through as you're continuing to plan and build and upgrade your networks. So in this age of digital communication, the last thing you guys want to be doing is spending a tremendous amount of time on a Zoom meeting or webinar. So for you guys to take just a few minutes of your day and spend it with us for the next 30 minutes, I really appreciate that. Thank you again for being here. Again, what we're going to focus on today is some network design issues and concerns that that you guys may be facing as you're heading towards the next generation of your networks. So we just want to, take some time. This is not a sales pitch. We're not even going to talk about probably what most of you are familiar with when it comes to Geograph is our GIS fiber management software, CrescentLink. We just really want to take some time and talk about our experience over the last 20 years in designing and building networks, and hopefully give you some insight into some things to think about as you move forward. So again, we're in the second edition of our webinar series this year. Back in March, we had a webinar of how and why to manage legacy networks utilizing GIS. There's a link to our video of that webinar that will be on this presentation when we send this out. And also you can go to our YouTube page, Geograph Technologies, if you'd like to view that webinar along with some other videos that we have about our product and services. Today in June, we're talking about things to consider for fiber to the home network architecture and methodology. Later this year in September, we're going to be talking about bringing spatial awareness to feasibility planning, kind of dovetailing off of the network architecture webinar we're doing today. And then finally, we're going to wrap up this year in November talking about how to utilize GIS to minimize operational expenses or OpEx. I know it's very important for operators such as yourself to save money when possible, to be able to bring that and give that value back to your customers at the end. So just a brief outline of the agenda that we're going to cover over the next 30 minutes. I just want to take some time and define what is FTTx. What does that mean? Then we're going to discuss the different design architectures, just on a very high level, really just talk about the structure of these design architectures and specific methodologies that you may take when you're overbuilding or building these advanced networks. We're going to talk about what to consider, things to think about when deciding on an architecture. You may already be in that phase, you may be complete, you may just still be researching and scratching the surface. So we really want to make sure we talk about what are the important things to think about when considering and deciding on the architecture. And then we're going to dive into the pros and cons of each method. Obviously, there's goods and bads with everything you do, and we're going to try to cover some of those for you today. And then lastly, we're going to finish up with a Q&A session. And with that said, should be at the bottom of your screen a tab for question and answers. If you have any questions along the way, please feel free to type them into the chat box there. I'll try to keep an eye on them as we go through, and if they're pertinent to the item we're talking about, I'll answer them. If not, I will respond to the questions during the Q&A session. Then we'll close up with some final remarks and hopefully send you guys on your way with good information. So first off, what is FTTx? So fiber to the X is a collective term describing a wide range of broadband network architecture options. Those architectures utilize optical fiber for some or all of their last mile connectivity. The FTTx is a key method, I want to stress that, key method used to drive next generation access, describing a significant upgrade to the broadband available by making a step change in speed and quality of the service. So first of all, I just kind of want to give a structural view of what the different architectures are, just so you kind of understand this. First one we're going to talk about is direct fiber connect, or sometimes we call these home runs. Sometimes the NOC will call them active E. But basically what this is designed for a single strand of fiber from the optical switch all the way to the end user. So no splits, no couplings, no diffusion along the way. This goes straight from the port at the switch all the way to the end termination. So this gives you that direct bandwidth connection from the source all the way to the optical network termination, or what we sometimes refer to as the ONT. Moving along to the next method is centralized PON, or centralized passive optical network. Now, what passive optical network means is that you're using splitters in the field to split that power of that light signal of that fiber. You're gonna split that and share that bandwidth among several individuals. Now, in a centralized passive optical network, what you're using is splitters coalesced or centralized at a central location, to where you have your optical switch, you have feeder fibers going out to this centralized location. All your splitters are housed in one location, and then you have a distribution network out to your ONTs. So as we talk about centralized PON, and this is the type of architecture and structure that we're referring to. Next, we're going to talk about distributed PON. So distributed PON is very similar to the centralized PON, with the exception of your splitters are not centralized in one location. They're cascaded throughout your network. So this uses the same technology and splitters, and it uses the same multiple of splitters, typically up to 1/32, but in a cascaded method. So you would have a single strand of fiber going out to maybe a 1/4 or 1/8 splitter. Those would then go to 4 or 8 more 1/8, 1/40, 1/4 splitters onto the distribution to the ONT at the end source. In essence, cascading and splitting that light in multiple locations. And lastly, we're going to talk about distributed tap. So distributed tap also uses passive optical splitters, but this time they're not cascaded or centralized. They're used in sequence. This way you have one power source, one light strand that is going into a splitter, tapping off to your ONTs or your services, and then continuing on. You may feed multiple splitters in cascade until you basically deplete that light source from the optical switch. So that's the 4 methods of architecture that are commonly used when building and designing fiber to the X, specifically for home, but this is also for businesses as well. You can talk about these architectures kind of simultaneous between the two. But what are some things to consider when choosing FTTx architecture? Well, there's several things that you need to think about prior to starting your projects, or even if you're in the midst of your projects. Growth is one of the most important ones to think about. Is the area you're designing growing, and at what pace? If you're in a pretty stagnant area, maybe full of agriculture and farming, you may have one methodology that you prefer versus what you have in an urban environment or a planned community environment, or one that's heavy with apartments and condos. So really understanding the growth of your area is something you should really take into account before starting your network distribution plan. Density. So what do we mean by density? It's really thinking about the number of businesses and residents per mile. How many services are you going to be providing in a mile of plant? So we kind of always bring everything back to a KPI of miles of plant. So how many services per miles of plant, cost per miles of plant. You know, all kind of KPIs surrounded around that. And density really affects how those numbers are calculated. And so understanding the density of the area you're working in is something to really take into consideration during your planning. Next, the proverbial squeezing of the balloon, capital cost versus operational cost, and where do you want to spend your money? Let's face it, everyone, you're going to spend money when building networks. And really what you got to consider is where do you want to spend it? Do you want to spend a lot of money up front in your capital cost and build a very robust network to reduce operational efficiencies and minimize cost effects of growth on the back end? Do you want to get the plant built quickly and cost effectively up front, but you know may cause you some troubles on the back end trying to keep it maintained and operational? Really, just kind of understanding where do you want to put that money. You know, it's always good to have a good balance there. So, but really taking into account not just what it's going to cost you to build it, but what is it going to cost you to operate it. Fiber has an economic life of, I believe, 25 years. So you really want to make sure you're getting the most out of the money for your network when you're talking about building fiber. And lastly, a consideration that I think gets overlooked quite a bit is the technical capabilities of your staff. What are your staff capable of working with? For example, if you do a direct connect fiber and you're bringing large count fibers out of your central office and you have a damage or a cut to a fiber, is your staff capable of working on those large count fibers? Can they manage the splicing and the handling of that? Another example, I was building a network and the majority of their network was buried, and they went into an area and built it primarily aerial, try to save cost and time getting the plant built. Well, after they got it built, their staff had a very difficult time maintaining that network. One, because they didn't know how to climb poles. They had never learned to climb poles, never had to. They only had one bucket truck in the whole organization. And so trying to save money on the front end by building a completely aerial network in a CLEC environment, they ended up having to spend a lot of money on the back end, retraining their staff and providing the materials that their staff needed to work and operate and maintain that network. So really understanding the capabilities of your staff and what they'll be comfortable with working with this network throughout the years. So which one is best? Unfortunately, one size does not fit all. There are several things to consider as we talked about. So I want to go through those briefly. So indirect fiber connect or the home run. So let's talk about the pros. As mentioned, one of the pros is you got a single strand of fiber. So you got a dedicated pipeline from the optical switch all the way to the ONT or the terminating customer. Very little what's the word I'm trying to say? Anyway, there's no data throughput limits. You have very few limits on how much data you can push through that pipeline. Really, the only thing you're limited to is the equipment on both ends, and that is constantly evolving and can be easily switched out as long as you have that outside plant network dedicated between those two devices at the switch and at the terminal. And it's easier to manage light budgets. Now, you don't completely do away with light budgets. Physics comes into play with everything, distance, splicing, temperature. There's lots of things that come into effect when managing your light losses in your budget. But it's much easier to manage that in the design for a direct connect fiber to the home. Now, on the flip side of that, there's some cons as well. As we mentioned, you may potentially be working with some very large fiber counts, especially coming out of your central office or your wire centers. If your central office is feeding, I don't know, a couple of hundred to a couple of thousand subscribers within a dedicated area, there's potential to have quite large fibers coming out of your central office that you're going to have to work with and maintain throughout the years. Typically, we see that this method carries a higher construction and splicing cost, and specifically because of the amount of glass strands that you have to be able to build this network, to utilize this architecture. And then lastly, a con is you have a high density you have high density trouble spots or bottlenecks. For example, within several hundred feet of the central office, you may have routes with these large count fibers. Well, just because it's within a couple of hundred feet of the central office does not make it immune to troubles or to being cut or damaged. So just imagine if you've got a 576 or an 864 fiber in the ground that gets cut, there's quite a large potential for a large number of people to be out of service because of that. So in our experience, this type of architecture and methodology is best suited for urban populations, city environments, planned communities, and condos. Something to where you can take advantage of close proximity density, to where you're not running these big cables in long distances, and you can really focus in on smaller areas to get a bigger bang for your buck. So that's direct fiber connect. Let's move on and talk about centralized PON. So some of the pros, this mimics traditional wire center design for those who are used to traditional telco operators, DSLAM cabinets, central office boundaries, wire center boundaries. This type of architecture and design very closely mimics that. And so it's easy to progress from a legacy design or a legacy record system into something new, and understand that all you're doing is changing the medium, but your design and network architecture stays very similar. Minimal access points again. So with all of your splitters and patch panels being housed at centralized locations, it makes it easy to go and do installs or troubleshooting because you have one location to go to versus trying to track those down throughout the network. Managed feeders. So what I mean by managed feeders is if you design your feeders to go out to just a couple of cabinets, small cabinets versus maximum design, if you can route those bi-directionally, there's several ways to accommodate, but if you manage your feeders, you can minimize your outages, which means that you can isolate your network really to very small contingents of your subscriber base. This reduces your outage potential based on the design of your network. Now, some of the cons. Obviously, the cost of cabinets and splitters are higher. You're typically using 1x32 splitters, and in most cases, multiple splitters at these locations. You also have to have the cabinets and the patch panels for your distribution. So you have the added cost of these cabinets and splitters populated throughout your network. And I look at a con, and it's hard to set specific parameters. So when you're looking at your network and you're looking at your area and you're planning out your builds, it's often a good idea to set specific parameters. You only want 288 cabinets or 432 cabinets per se. You want to keep your wire centers or your FTTx locations small counts or large counts. With this type of network design, it's really hard to settle in on one specific size, because there's some areas would require larger cabinets, some are smaller. And so you may have a different mix of cabinets that you need to plan for and logistically order and have housed. Also, high potential for dual network routes. And so what I mean by that is you're going down a road or a pole line out to a feeder for an FTTH cabinet. It is potential that route could carry transport fibers, feeder fibers, as well as distribution fibers, all within that one route. And so again, you have a larger potential for service disruption along those routes where you may have transport, feeder, and distribution. So what is this best suited for? We think it's best suited for traditional telco operators, traditional providers that are looking for consistency. You're looking to upgrade your legacy network, but you're hoping to keep a very consistent look and feel for your staff to work with. Next, let's look at distributed PON or distributed passive optical network. So pros, this can utilize low count fiber because you're multiplying these splitters throughout your network. You don't have to have large count fibers coming from a centralized location or from a central office directly. You can manipulate and use low count fibers throughout your network to be able to connect a large number of subscribers. If you're using the smaller splitters, the 1x4s and the 1x8s, these are typically less expensive than the 1x32s, so you can save some money on your equipment there. And then high utilization of glass with backfeeding. So if you've got let's just say a 48 strand fiber going down a road, you can use that in both directions, and you can get high utilization of the amount of glass within your network versus being a tree hierarchy where you start and drop off, and you may have a lot of dark fiber or dark glass within your network with other architectures and methodologies. So this one utilizes the majority of the glass. Now, cons. It's difficult to design and manage operationally due to inaccurate ground truths. So what do we mean by inaccurate ground truths? Well, I would venture to say that probably 80% of design and planning is done behind a computer screen using aerial imagery or records that have been updated and maintained over the years. And needless to say, there's going to be mistakes in that. There's going to be missing information. Maybe aerial imagery is not up to date, and potentially you could miss addresses, you could miss services and poles. And so if you're designing this network very thin to utilize low count fibers and you miss things because of inaccurate truths, it could potentially cause a lot of disruption in your service moving forward, trying to accommodate those. High growth can also disrupt the services or cause costly rebuilds. Again, if you misplan or maybe someone drops a new neighborhood in along the route and you don't have the capacity or you don't have the strands of glass to be able to accommodate for that, potentially could be right back in the same location building again in a couple of years. And then numerous access locations to manage. With your splitters being cascaded throughout your network, you've got to keep up with where all those locations are at. To a service location may have to go through 2 or 3 splitters, and knowing where those are at and being able to manage those becomes tedious at times. So we feel that this is best suited for those in rural organizations that may have a lot of existing fiber routes and have low density growth. For example, farming communities, somewhere where the land is going to stay land. There's not going to be a huge expansion or a very quick expansion of services. This network architecture can really come in handy in those cases. Then lastly, distributed tap. Pros. Again, you can utilize low count fiber because you're stretching the power of that light as far as you can, and you're getting the most resources out of that DB budget that you have. Minimizes large splitters. Again, you're not co-locating large splitters and putting that cost into a centralized location. You're putting those at the service locations and using the smaller ones to save money. And then low cost initial capital. We've seen in our experiences has showed us that this is the easiest way and the cheapest way. I wouldn't say cheap, the lowest cost way to build networks quickly and efficiently. It works great, and it's good to keep that initial capital cost low. Now, some of the cons, again, you got to manage that light level. When you're stretching that DB budget as far as you can, and you're trying to get as many services as you can off of that light budget, you really got to have good metrics and good measures to make sure that you're not planning on serving someone with a light level that's not going to operate their ONT. So you do have to keep careful eye on managing those light levels. It's hard to account for future growth with this. If you design it very tight and you don't account for a lot of extra growth there, again, you could have the same situation where a large neighborhood comes in, or maybe addresses pop up along the route that you've already had built and connected, and so it makes it hard to kind of manage and account for that future growth in those areas. And then again, the need for sophisticated management and design platforms. When you're calculating these light budgets and estimating how many strands of fiber you're going to need, and how many splitters, and how far that light can go, it's not something that can very easily be laid out on paper. You've got to have some sophisticated systems to be able to do that for you. So we think, this is best suited for organizations looking to build large geographical areas very rapidly with low upfront capital cost. I know with a lot of the RDOF funding, a lot of um, the mechanisms for funding that's coming out, they're very time sensitive. So this may be a good way to quickly get networks up and running to get to get those funding options taken care of. So we've got about 5 minutes left. I want to just go through some final thoughts, and then I'll open it up for some question and answers uh, to get us through this afternoon. But final thoughts are always just plan ahead. Um, it's very, as we've seen, it's about 1 to 2% of a total project build to go ahead and plan and lay your entire area out. With the softwares, with GIS, with the expertise that's out there, it's very easy to look at at a complete area, lay out the entire network plan, outside plant, all of your equipment, and build a plan. Doesn't mean you have to build it all. Doesn't mean you have to build it all at once, but at least plan ahead. It's a very inexpensive way to make sure that you don't back yourself into a corner. And then think ahead. A lot of times people just decide because of the technology, and they don't really think about the things we talked about earlier of what to consider, to think about your staff and how they can handle this network moving forward. Think about what's next, what's beyond. So many times we want to look at what's directly on our place or what the immediate need is, and we fail to look what's beyond that. So just always make sure you're thinking about not what's right in front of you, but what's ahead of you as well. And then lastly, ask for advice. Um, it's very typical that you may have 15, 20, 30, 40 years in this industry, but you've been with one organization. Ask for advice, ask for consultants or engineers that have worked with multiple companies that have been uh, very versed in the industry. They're good resources, and they've typically experienced this at some point in their career. This is also a service we offer here at Geograph is planning network design. It's something that we would be glad to help you with as well, because we're not just software developers. We're telco junkies, and we'd love to help you out with that if the need arises. But really just plan ahead, think ahead, and ask for advice. So with that said, I'm going to open it up for questions. We'll go to our Q&A session here and see if we have anything pop up. So here's a question. What happens if we make the wrong choice? Well, congratulations. You are human. Everyone makes mistakes and the wrong choice. But the good thing is that it's material. It's always overcome. You can always overcome it. Again, that's why planning ahead and thinking ahead and being prepared for what might happen is one way to mitigate making the wrong choice. But don't be worried to make the wrong choice. Again, with it being material, it's always fixable. So here's another question. Do you see a method more common than others? Again, no, we really don't see one way standing out. It really depends on the organizations you work with. Again, I grew up in the rural telco. I was a consultant and engineer for rural telcos throughout the Southeast. And they tend to generalize towards the centralized the PON network. And so, but does that mean that's the right way? Not necessarily. You got to find what's right for you, and there's good and bad for all of them, and it's really just understanding what's most important to you. So we have a comment. Project creep is always an issue. Uh, this organization designs for others, and they always want to get that next house down the road. When designing, everyone needs to think about that. That's a great point. Again, it's just being able to understand and look ahead and putting that plan together. That's probably the cheapest part of your network build is planning. So take advantage of it. Get a plan together, get it laid out, and work towards that. So question, do you ever recommend a mix of designs? Absolutely. I think that's a that's a great point. You can definitely have hybrid systems of centralized split in certain areas and direct fiber connect in another, and distributed split and distributed tap. Definitely can mix it together. Really, it again just depends on the area, specific to what you're doing and what you're willing to and capable of maintaining. So another comment: hybrid systems of distributed tap and GPON is common, and do we find that in other areas? Yeah, I think so. I think the distributed tap is becoming very popular, especially with so many power companies putting fiber up. It's a good way to string fiber and utilize it. They've got really good records. The passive optical network has shown to probably be the most cost effective, gives you the most bang for the buck, and with 10 gig pond and X pond and everything that's coming down the road, it's as easy as changing out the equipment, to upgrade those services. Great question here. Do you know of any tools or software that provide light budgets for all of these architectures? That's not a loaded question. That's actually, yes, Crescent Link, our tool at Geograph, actually does that. We calculate light budgets for loss through splitters and all of the different architectures. Feel free to reach out to us, and we'll be glad to talk more with you about that. But yes, our software Crescent Link does provide that. So another question: cooperatives and utilities are now doing fiber build outs. What do you see more with them? So I'm assuming when you're talking about cooperatives, you're talking about electric cooperatives and electric utilities. It's a mix. I probably see the majority. I know we have several customers of ours that do design and planning for cooperatives and utilities, and they're doing distributed tap and cascading splits. Really just because they're trying to take advantage of those funding options, and they're trying to get the most bang for their buck. Also working on some projects with some rural utilities, cooperatives that are doing centralized split. So it's really a good mix of both. Again, if I was asked my preference, I just like the centralized split. I think it's a very good mix of capital cost weighed against operational benefits in the future. It's the best way to set your network up, for that growth. And then lastly, another question: one last question, how do you account for unexpected growth, i.e. neighborhoods? That's a great question, and that comes up a lot. You don't really know. A lot of times you build these networks, and the next year someone inherits a couple of 100 acres, and they develop a neighborhood there. It's really what's more important is focusing in on the pathways and what you have available. If that means extra duct, if that means designing in a few extra fibers for feeder in the future, it's really not necessarily needs to be accounted for in your fiber design. But as long as you're taking into account of how you will address that, that's the big thing. It's just understanding how you will address it when those situations come up. So again, we're at the end of our time. I appreciate everyone attendance today and participation. And just as a reminder, you will be getting a link to this video. We'll be sending out the slide decks, and it will also be available on our YouTube page for future viewing if you'd like to share it. And then a reminder that in September, put this on your calendar. We'll be bringing spatial awareness to feasibility planning, a little more dovetailing off of this discussion. And closing out the year in November with utilizing GIS to minimize your OpEx. So if you have any more questions or would like to discuss these topics further, feel free to always visit us at geograph.tech or email us at info@geograph.tech, and we'll be glad to get in touch with you and help you out with further discussions. And with that said, I want to thank you all again. I want to be a good steward of your time, and enjoy the rest of your day. And we look forward to working with you again very shortly. Talk to you all soon. Have a great day. Bye-bye.